Okay, now we want to find out how can light be used to identify minerals. So in order to do this, we first got to know what light is. So light is an electromagnetic wave. And so that very first picture there is of an electromagnetic wave. So you can see that it's wavy. So it's a wave. Let's say that it's traveling in this direction. And the thing that is sticking up and down is the electric field. So we're going to use the letter E to stand for the electric field. Now, the electric field is created by electricity. So any electrical charge is surrounded by this thing that we call the electric field. Then, perpendicular to this electric field is going to be a magnetic field. So it's kind of hard to draw, but I'm going to draw it like this. So here's the magnetic field, and it's going to be perpendicular to that electric field. So if the electric field is up, the magnetic field is going to be pointing sideways. Now, you should be familiar with magnetism. So like a magnet produces around it a magnetic field. So light is partially electrical in nature, and it's partially magnetic in nature. Now, if you were to look at it as it's coming towards you, what you would see is the electric field pointing up and then the magnetic field pointing sideways. And now, the electric field doesn't necessarily have to be straight up and down. So that light coming from the sun, some of it is polarized this way, but then some of the light also has its electric field pointing this way. And some of it has its electric field pointing this way. So this series of lines shows you that the electric field can basically be in any direction that it wants. And perpendicular to every one of those arrows would be the magnetic field, which I'm not drawing. So that's unpolarized light. However, we can polarize it by sending it through a polarizer. And a polarizer is going to be a piece of plastic, and then it's got crystals embedded in that plastic, and those crystals are oriented like this. And so what they do is they kind of make a picket fence that when this light passes through those crystals, each one of those crystals will only allow an electric field that is up and down to pass through it. So that once this light passes through that, then what you end up with is an electric field that is now straight up and down. And so that's what that second picture is trying to illustrate. So how can this help us? So what we do is we go out in the field, we get our rock. All right, now that rock is made up of minerals. We want to know what are the minerals in that rock. So we're going to take the rock and we're going to start to grind it down thinner and thinner and thinner until finally that rock is only about 1/10 of a millimeter thick. So it's going to kind of look like a pancake, but it's going to be so thin that you can see through it. Okay, now what we're going to do is we're going to take polarized light and we're going to pass it through the mineral, the rock that's composed of minerals. So polarizing light is going to shoot up through that thin rock, and then we're going to observe it in a microscope. Okay, but then what we're going to do is take the rock, that thin thing, and we're going to start to rotate it. Okay, we can rotate that rock. Now, when the polarizing light going up encounters a mineral again, and if that mineral is aligned with that polarizing light, then you see the mineral, and it's a certain color. But when we rotate it, if that mineral crystal is out of position, so it's not parallel to the polarizing light, then you don't see the mineral. And so by rotating this around, what you're going to see is sometimes minerals will become visible and sometimes they'll become dark, and based on the color and the shape, we can figure out what those minerals are that makes it up. Pretty interesting. Okay, let's take a break, and when we come back, we're going to talk about seeing the minerals.